episode of Indigenization Appreciation Hour. I'm Saurav Jha, and with me is my long-term associate Sriram Tyagarajan. So today we are going to talk about the fact that India has, well, it's very likely that India has finally settled on a foreign engine house with which the country is going to partner for the development of a next generation turbofan. Initially, it was believed that it would be for a next generation low bypass turbofan. So basically, a fifth generation engine was what was being, looked at. But we are not quite clear whether it's just going to be a fifth generation turbofan, or it might be closer to what we call closer to what is basically would be a sixth generation turbofan, which would be a variable cycle engine. Now, even if you keep aside the possibility of the tie-up being for a variable cycle engine, the fifth generation turbofan effort, and if it is indeed just a fifth generation turbofan effort, even in this, I think we are going to see some very novel technologies being incorporated, given the kind of things the the chosen foreign OEM or foreign engine house has been working on. And in this case, of course, if we go by reportage, the chosen engine house is Safran from France, right? At one time Snecma, now Safran. They are the ones who are supposed to have been down selected, although obviously no sort of contract or anything has been signed yet. And in any case, this is going to be a government to government partnership, so we haven't seen anything anything being inked as of now. But if you go by credible reporting, it seems that Safran is indeed the sort of winner of the competition that was run for selecting a foreign engine house to assist with, or rather to collaborate in the development of a next generation turbofan. So if we assume that it is indeed Safran who has been chosen, and by all accounts that seems to be the case, then we are basically, then it means that the Indian government has gone with a long-standing partner in the form of France, in the form of the French government. Now, typically as things stand, if the French offer something, if the French sort of put their hat in the ring for some kind of competition of this sort, where it's going to be a G2G matter, it usually means that they have already been cleared by the government to do so. As in, Safran would not even have entered the fray without the acquiescence, or rather without the endorsement of the French government. And it would also mean that a certain various classes of technologies would have already been approved by the French government for co-development, or for the purposes of mutual exchange, etc. So that we must keep that in mind. And the fact that we've chosen them shows the degree of sort of comfort and trust that India and France have for each other. This is definitely a marker of that, because this is not going to be a commercial deal. Like I said, this is a G2G, a government to government agreement. So that is one thing. Now, I would say, given how these things happen, I don't see the Indian side entering into a collaborative venture like such as this without getting the foreign engine house to upfront, or a priori, basically, that is a priori commit to performance guarantees for the engine, right? So they will the chosen partner is going to guarantee the performance of whatever engine is ultimately sort of developed and produced. Let us be clear about something. Nobody is going to upfront guarantee to some specific performance. That they will do only in the course of the deal itself. So any such deal typically has an initial development phase, which is when product requirements and performance specifications are mutually sort of hammered out. That whatever is hammered out through the initial development phase is what the foreign engine house will have to commit to in terms of performance guarantee. And naturally, they will have to they will have to partner India throughout the course of development, all the way up to certification, and then I guess production as well. Because I am quite certain that New Delhi would not have entered into this arrangement if it did not include a very deep collaborative arrangement on the production side of things as well, not just on the technology side of things. It's not, I mean, this is not an arrangement to enter, to just develop that is aimed at developing some just some prototypes and to be done with it. That is not the kind of so-called TOT arrangement that, I think India was looking at, and that is why this selection process has taken as long as it did, although it probably should have been done earlier. But then, of course, there's no point in going into what could have been done earlier. But now that I think it is underway, a very sort of a very important decade, a very important period of a decade lies in front of India, because this decade is going to be a defining decade. And if this collaboration is done right, and we will talk about how it could be done right, we will emerge on the other side as a true aerospace power. It would actually lay the foundations of India becoming an aerospace superpower if it is done right. So that is how important it is, and that is what is at stake. So anyway, so let me bring in Shriram to get his initial thoughts on the matter. After which we'll go get into a few details of what this arrangement might entail, and what are the things that we need to do, that the Indian side needs to do to ensure that it is worth the time and effort. Over to you, Shriram. We can hear you. I can hear you. I don't think there's an issue. Okay, let Shriram figure that out. But yeah, like he's about to say, the collaboration with the French is not new at all. So when Safran was still called SNECMA, they had been roped in at various. They have the SNECMA had actually been roped in at various points of time for design reviews and stuff. And I'm obviously talking about the Kaveri, Kaveri jet engine development effort, or rather the Kaveri engine development program, as it was called, KEDP. That program has, of course, been closed, but then follow-on programs are underway, as you know. We'll talk about that also in a bit. But
Yeah.
as Sriram is about to say, are you ready, Sriram?
Yeah. I'm.
Okay, please go
Sorry
ahead.
for that.
Yeah.
So the collaboration with the French is not new at all for GTRE India, right? We've had collaboration, technical collaboration, be it support for manufacturing some of our designs, or even say design consultancy, even during the 90s and especially during the 2000s, when we identified a lot of substantial issues with the Kaveri itself, and we brought in the French to take a look. And in the late 2000s, we even had the once the engine itself was delinked from the Tejas program, then there was all this talk of how to power the Tejas fleet. And then one of the options then was the French offer to use the M88 engine's core inside the Kaveri, using the Kaveri's existing low pressure, low pressure section, afterburner, and everything with with an M88 engine core. So that option was actually forwarded by the DRDO itself to the decision makers at that point in time. And I mean, rightly or wrongly, that option was shot down, I think, predominantly by the Indian Air Force, because they said, we need an entirely indigenous solution for an indigenous fighter. And this seems like a cop-out, because the core is pretty much the engine. And if that comes from outside, then I guess let's say we won't really take it. I mean, in hindsight is 2020, and if you look back at that option now, I would still say that would have been a good option to take. Would it have been as good as the GF404, or would it have had enough, maybe we could have paid the French to develop another engine for us, co-develop, right, an engine for us, to get to the GE 414 class of turbofan engine to power the subsequent variants of the Tejas itself, be it the Mark II or the 10VF or maybe even the AMCA, right? We could have used it as a stepping stone before getting onto the whole variable cycle engine part of things. Perhaps we could have retained a lot of talent and brought in more talent if we had continued evolving from there. But again, like I said, it's hindsight is 2020, and despite all the flight campaigns in Russia with the Kaveri engine itself, once the D-Link happened and a decision was taken to not go down this approach and go towards the American engines, the Kaveri effort pretty much withered away until 2014 when it was eventually shut. And now we have an answer from parliamentary questions yesterday on exactly how much we've spent on the KDE program, right? There was a tweet from PIB yesterday. We had also tweeted it out. I think the total was some 714 or 740 crores in total.
No, just to be clear, okay. For the Kaveri derivative engine effort, a sum of about just under 1100 crores was sanctioned, okay. That is what was sanctioned in 2017. I think that 739 crores that you're seeing are funds that were supposed to be spent on creating a flight-worthy example of the Kaveri and integrating it onto a Tejas test vehicle. I think those funds are now being directed towards doing the same for the KDE. That is what you're looking at.
So these, you're saying, are additional funds?
Yeah, these are additional. These are separate funds, most likely. These are not funds. These are not part of that 1060 crores, which is supposed to have been spent on the, what is called on the Kaveri derivative engine, as it was sanctioned in 2017.
Correct.
Right? Okay.
Anyway, however, the funding scenario is, this is all after 2014, where we were going to take the low pressure and the high pressure section of the Kaveri, deleted the afterburner section and use it as a dry version to power the UCAV, which is going to be a subsonic platform anyway, and doesn't need the afterburner section because it's not going to push you supersonic. But the whole problem with our engine efforts over the last 20 years has been, once it was determined that the Kaveri isn't powerful enough to power the Tejas, thereafter the whole effort and importance given to the program has fallen off a steep cliff, right? Once that decision was taken that we've now delinked and we're going to look at some other option, the effort into creating design challenges, nurturing talent, bringing in more talent, creating facilities, that entire decade plus of effort through the 90s and the early 2000s, but nothing has been built on top of it, right? So you've people might call me names, but I would say that in terms of aircraft development, right from the late 80s, we've had continuous work being done on aircraft development. Right, we had the earlier TD, PV, phases, and then the IOC, FOC phases for the Tejas. And meanwhile, you also had the Mark II program going on from the late 2000s, and then the AMCA program also began, even if it was a small program. So you had successive programs being created, which means that all of that knowledge that you gain has been passed over and institutionalized in ADA as well as HAL and every other organization that has taken part in the whole program, right? So that kind of knowledge sharing and knowledge transfer, carrying over all of that work that was done in the early 90s, late 80s, and all the way through the flight test program, in the mid 2000s. That needs to be carried over, right? Because the guys in the 90s who did all of the work haven't had anything else to do except for the KDE programs, LP program. I mean, there's continuous lab scale programs going on, but it's not like a mission mode new engine that you're developing, isn't it? Or even a substantive variant or a derivative of the engine that you've developed, even though you have tinkering and progressive evolution of the Kaveri itself through the 9 or 10 versions of prototypes that were developed. So this is extremely important when you have cutting edge engineering design, right? Carrying over all of that knowledge that you gain. And we've talked about this so many times, what DRDO products or IDDM products on the whole, how you have to complete the cycle, right? You design, manufacture, get data from usage, plug it back into the next generation design, isn't it? Sure, the Kaveri V1, let's call it, wasn't optimal, right? It was overweight, didn't produce enough thrust. The LCA itself was overweight. So that the product never gave you enough data, but you should have still gotten enough data out of it by flight testing it and plugging it back into another program. The testing didn't happen, we didn't have another program to plug it in, and we're doing the whole thing again 30 years later, right? And because we didn't do all of this in a lot of other issues, we're having to go back to the French. In hindsight, it looks to me like if we had taken the M88 core and worked on that program and had a follow-on program with the French, doing the same thing that we're doing now with the Kaveri, if we had said we want to co-develop a operated version of that engine, maybe we'd have been in a better position. I don't know. Yeah,
Oh,
but
well,
that's
see,
my
it's
view.
like this. What the French wanted to offer at the it's always a question of how much value you are getting for your money. What the French had been offering earlier was not considered to be valuable enough. See, the program, as you mentioned, we've long been in discussions with the French, and of course, as you said, DRDO itself had that proposal for a sort of M88 core using version of the Kaveri, right? Sort of a Kaveri 2 is
Yeah,
what it was sort of unofficially called at the time. But that was in any case, that would have at most, theoretically it would have generated 90 kn, but even people were not very certain that it would have done so, right? And 90 kn would not have been sufficient for what became the Tejas Mark II. The Tejas Mark II also underwent a lot of capability and concurrent, size growth through the course of its various iterations. And finally, we ended up with what was being called the medium weight fighter at one time.
yeah,
So for that, we needed something which was in the 98 kilonewton class, and neither the French nor the British really had anything at that time. And the only thing was the F414 that we could have tried, or some Russian engine brought out of cold storage. That would have been the other option for said purpose. So that is why that sort of thing never went anywhere. Well, but your point generally about, we should have definitely progressed the Kaveri, baseline Kaveri itself, and at least done a limited envelope testing on a Tejas test vehicle by now. Through a series or through successive Aero Indias, one kept hearing that it was just about to be done and sanctioned, etc. Because in the Kaveri program, as it was sanctioned, a certain quantum, that 739 crore kind of quantum, was actually kept aside for integration and flight testing of the engine, right? And around two, and through a series of PDC revisions, the flight had the development cost had come to around 2133 crore or so. 2133 crore was the development cost, and if I'm not mistaken, something like 734 crores, right, was the cost for basically integration and testing, which I suspect is what has now been apportioned to the KDE. Because see, it cannot be that these are amounts that have been spent from the overall sanction, as some people are suggesting, because it specifically said that this is what was sanctioned for this and this is what was sanctioned for that.
yeah,
Whereas, as we know from earlier parliamentary reports, that 1069 crores or so was basically sanctioned for the KDE program, and that is what must have led to those two prototypes that have been tested in Russia, the high altitude engine test
yeah.
facility, etc. But now they are going to basically make flight worthy prototypes, which are
Okay.
which are also going to be tested, and then they are going to and then it's going to integration is going to cost a certain amount of money. I think what you're seeing.
We have to pay the Russians anyway, let alone flight testing the whole thing.
Yeah, and honestly, even with this co-development deal with the, co-development plan with the French, which is in the offing and will become a deal that is inked, I think, quite soon. We are not going to let go of the Russians either, because the Russians also need to advance their jet engine technology, and they cannot do it all by themselves either. See, one big difference between 1989 and now is a lot of water has flown down the Kaveri, and what has happened is that we have clumps of industrial capability, and GTRE is learning. GTRE is also at a much higher point on the learning curve, and the successful sort of prototyping and the creation of this Kaveri derivative engine is a testament to that.
Yeah.
However, having said that, one of the main learnings of GTRE has been is that they are not going to launch into actual prototype development before attaining TRL 6. Okay, they into sort of final prototype development, not initial prototype development. Which is why circling back to the whole thing, the initial development phase negotiations between India and France are going to be of paramount importance, because what will follow after that is the work on subsystems, essentially, right? Subsystems and various parts and components with clear mapping of who's going to produce what.
Okay.
See, the French will say that, oh, all this will be produced in France initially, and then we will transfer the tech to Indian industrial partners subsequently. That is where we have to insist that no, the Indian industrial partner has to be on board from the very beginning. This process of I will get the parts first made by somebody else somewhere else, and then or major subsystem. Say, I'm talking about at the module level. Say the high pressure, various parts of the high pressure core. What France will say is, oh, the high pressure turbine blades, let these be sort of cast in our existing facilities, and subsequently we will develop an Indian industrial partner for this. This is where we will have to put our foot down, and we'll have to say that we'll have to move on this credibly from the very beginning, not from later or anything, because this is going to take time. No
Yeah, just
engineer.
to jump in. So the whole HAL GE deal on manufacturing the GE F414 for the Mark II and the early versions of the AMCA and anything else. There was a long list of technologies that we're supposed to get, as part of this deal, where it's mostly manufacturing, right? I forgot who listed them out. One of them was a cooling hole drilling on blades and combustors and vanes and everything. Then I don't remember if TBC application was there, but there was no mention of, or was there mention of casting for the
TBC
high pressure blades?
application is very much, you're talking about the license production deal, right?
Yeah.
TBC application is very much part of the deal, supposedly.
So
the TBC itself is not part of the deal. That will come in a box.
So the material for your blades and the TBC powder itself will probably come from there. I mean, most likely. So what I'm saying is, through that deal, we will get capability to do all of these, right? So somebody who can do this for one particular design can also do the same thing for another design, right? So what it needs is trained manpower and institutional knowledge transfer for that. So what I'm saying is, if we do have these, or if we're getting these, then we can ask the French for more, right? Because we do not have an engine program where we're doing all of this at the moment, despite the fact that we have private sector companies like Godrej and Tata and everybody who build parts for commercial engines for all of these big airline engine makers. So the point about lacking in industrial capability for doing such so-called high tech that us brownies can't do, right? So that will in my opinion not fly, or at least we won't let it fly, which is what you were talking about, right? So the whole point of getting an Indian private sector collaborator, right, or partner, if you want to call it, as part of the initial process itself, will be something that our people will look to do. I mean, that is what I'm just reiterating what Saurabh is saying.
Yeah, I'll tell you, you're right. I'll tell you one thing. If you look at the LEAP, there is a certain major industrial player in India who already builds 20% of that engine by value and has the capability to address 60% of the requirements of that engine from a manufacturing perspective. So, like I said, any notion that, oh, these parts will initially be done in France only and we will, the first stage of prototyping will pursue that way, should be something that should be pushed hard against. From the very beginning, there should be an emphasis on the Indian industrial partner being involved, and the
Correct.
Indian industrial partner supply chain being involved. That is one thing. And see, the other thing is, okay, see, Amane Rautre is saying many things. I'll say two things to him. First of all, do not spell my name with BH. Okay, that is one thing. Make sure that my name is Saurav for all those who came late, not BH. The meanings are also very different, by the way, Saurav and Saurabh. And so be clear about
Oh, I
that.
thought
The
it was just a
second,
Bengali thing, Bengali
no,
Odia thing.
it's not a Bengali. It's a Sanskrit thing. Saurav means something. Saurabh means something else. Okay,
Okay.
Saurabh with a bha. Anyway,
Okay.
so that's one thing. The second thing that we have to be clear about is that the Kaveri code had a whole bunch of problems. To say that it did not have a bunch of problems is wrong. Okay, there was fan flutter, there was compressor flutter, there were issues with the combustor chamber also. So there were a whole bunch of issues that had to be fixed over a long period of time. It was not only afterburner screech that we were dealing with, right? So there was flutter in the low pressure compressor section, high pressure compressor section. There were issues with the blades also. So all of those things had to, I mean, the high pressure turbine blades and stuff. So all that had to be fixed. And the one of the reasons why we took so long to fix it is because we didn't have and still don't have our own test facilities.
Yeah.
So if you have to, write a letter to the Russians and then wait for 3 years to get a reply from them which says, oh yes, you can bring your engine on so and so date, then you are really, staring down the barrel of a gun as far as
Yeah. I
meeting
mean, what should
timelines
have
is
taken
concerned.
6 to 8 months now takes 3 years. So
No, in the
an
case of
engine which should have been
India,
ready.
it took 5 years. 5 years for what? And in the case of Flutter, it takes, say, fan Flutter, it will take 5 years for the best. F119, it took 5 years. Now,
Hmm.
in India's case, it took bloody 12 years. I'm sorry for that cuss word. Edit it out later. Anyway, so
No, but
whatever
see,
be the
that's the whole point, right? So if you have your own test facility in your next building, time to iterate is very little. But if you have to go abroad, and especially if you take the condition, in the 90s and early 2000s, then you can imagine how bureaucratic the whole process was and how difficult it is foreign policy wise, right? So, and you're also giving away information about your program's status at that time to, uh, you can't even call them friendly
No,
countries.
no, forget about program status. You're giving away everything to them, really.
Pretty
Okay,
much, yeah.
yeah. Program
So,
status is the least of your concerns. They'll know all the ins and outs of your design and exactly, its various signatures, which is the most
yeah.
important thing, really. So that is one
So,
thing.
yeah. So now, if you take a look at the technologies that we might get from the French, right, or we're looking to get from the French, some of them would be, let's start from the back, right? We're looking at LPT turbines. These most likely would be gamma aluminum, aluminide, turbine blades, not nickel alloy. Gamma aluminide is closer to titanium density, right? It's about 3.97 grams per cc. So it's a lot lighter than nickel alloy, super alloy that is used for the high pressure turbine, which would be, upwards of 7 grams per cc. So you're looking at a lot of weight
Nickel
difference.
is over 8.2.
Yeah,
Any nickel based super
depending
alloy.
on the
Yeah.
variant and generation, it's
Specific gravity is
7
over
plus. Yeah.
8.2. Yeah.
So casting, we have a lot of research going on this particular type of alloy at IISc and a few other places, but we are nowhere close to fielding operationally such a blade. But these blades are already in service with LEAP engines. Safran has been building, I think it's G4822 alloy, right? And they've been putting them in CFM engines. For a long time. I think they put it in place in 2016 or 2018. So it's been there for quite a while. And remember, Safran has a facility in China which casts and makes these blades for the engines that are integrated in China. So you can imagine, how much the civilian side of things matter, which is why we keep saying, the government should push for local assembly and local manufacturing on the civilian side of things also.
It'll matter for other things also on the design side. For instance, if you're not looking at a 3-steam adaptive cycle engine, you might be looking at variable pitch compressor blades, right? You might be looking at variable pitch compressor blades to effectively alter the bypass ratio for different regimes, super cruise and stuff like that. And Safran Aero Boosters has been working heavily on that in that area. Safran subsidiary, or say division called Safran Aero Boosters. So you have a whole bunch of things that might be on offer that obviously we don't know about because it's all classified information. But
Yeah.
when this thing actually takes off, that is when a lot of this information might be made available for public consumption as well, and that is when we'll know for sure. As far as the high pressure turbine section is concerned, the blades will likely be made of
Yeah.
made of
This is from a 2021 test, where they're just begun testing their new high pressure turbine blade design for the FCAS NGE. Next generation engine is what they call it, right? So they set up a new facility at Geneviliers for the FCAS program and some civilian side engine work also. So this was a brand new turbine blade design with new cooling technologies with respect to hole design and placement and size and everything. So this is already under technology development, right? So it's been 4 years since they've begun. So I'm pretty sure we are asking for some of these technologies because the AMCA is going to be from 2035 all the way for another 2.5 decades, right? So I'm sure, if you're going to ask, might as well ask whatever is the latest. And the NG itself, right, has a very, let's say, a curious timeline. If you look at it, this is from, the Dassault, let's say, timeline website itself. So you can look at the R&D TE phase, right, as well as all the way to the engine development phase. So you can imagine it takes a whole decade for the base R&D to be done, and then they build a demonstrator, learn from it, run it thousands and thousands of hours, and then get into prototype phase, right, which is the actual engine that they're going to build, and that will go into service, right, 2040 onwards. And given the way the FCAS program itself is being run, we don't have any idea if the program itself will run on that schedule, but the technology development is already in progress because what they want is to develop everything themselves. They just need the money, right? Which is why they're pulling in partners from everywhere.
That is what they'll want, but they also need human resources. And once our test facilities are made, they will want to use our test facilities as well. And so somebody was asking, does this $7 billion or whatever that has been projected, 61,000 crores, does it include test facilities or not? I think it most certainly does. It has to include the creation of a high altitude engine test facility, the creation of Indian flying, the acquisition or the creation of an Indian flying test bed, open air test rigs, and also very specific module test facilities as well, right? Specific compressor test facilities and stuff. And that is going to be also something that is not only going to be discussed in the initial development phase, but also in all the work that will go towards progressing things to TRL6. Because and why do I keep saying TRL6? Because this is what former directors of GTRE have said publicly, is the idea that nobody is going to jump into a mission mode sort of thing before attaining TRL6, because that is the mistake that was made with the Kaveri, right? In 1989, a mission mode
project, a parallel program where we are developing technology and trying to put it into working engine
and getting an engine ready in a span of just 7 years between 89 and 96,
without having any
with
facilities.
a total investment of only 384 crores, a little less than that actually. So this is where we were at. I don't think those mistakes are going to be made again. But the main thing, as I keep emphasizing, we have to look out for is the acquisition of the concomitant manufacturing technology. Okay, many things go into a fifth generation or so-called variable cycle engine. I'm sure even in, even what was envisaged for a so-called fifth generation engine in 2019 is not what is being looked at
Today, yeah.
right now in terms of material use. Okay, Sriram mentioned one for the low pressure turbine blade section. I can talk about, I'm sure this particular engine effort will see greater use of CMC, ceramic matrix composite. It'll see greater use of PMC also. I'm
Yeah.
not so sure whether we'll be using metal matrix composites for the shaft section or not, for the for the connecting shafts. But we'll definitely see greater CMC use on the nozzle side. you know I don't know whether the combustor liner will be CMC or not. Maybe that is also going to be explored, we
Might
don't
be
know.
there. Yeah,
So,
because
but
the
one
French
thing
are
is for
very
sure,
good at composites.
Safran is going to say, hey, I have all this pedigree and I'm going to take the lead on the high pressure core, which is the high pressure compressor, the combustor, and the high pressure turbine part.
Yeah.
And that GTRE will be in assist mode for all those. Here also, we have to be very clear as to what this assist mode will be. Because see, Safran is saying, what is Safran going to say as part of this? We are going to serve, we are going to be with you throughout development and certification, and we are going to guarantee the performance of whatever you decide via the initial development phase discussions. This is what they're going to say. But that's all very nice. But the point is that we just don't want a working engine. We want a working engine ecosystem, right?
Yeah.
So
And
we
not
have
just
to,
that,
yeah,
it's
what do you
the
think?
ability to work on that engine and create version 1.1, 1.2, 1.3, 1.4. You know, so where you take the engine as it is and keep working on it to troubleshoot as you put it into service, as well as create while the engine is still in production, create a Mark 1, Mark 1.1, 1.2, 1.3, where you keep tinkering and producing better designs, better manufacturing, better yield, however you want to call it, right? Whichever better, let's say, life, for instance. You put the engine into production, and then the Air Force comes back and says, this particular part, it's rubbing out very early, or we're seeing failures in this particular part very frequently, lesser than what we expected. Can you redesign this part, or can you figure out a way to manufacture it in a different way so that it doesn't fail so quickly? So we should be able to do that. Right. So that is what we're trying to learn while doing this co-development, agreement with the French. Yeah. Sorry, I jumped in, but I wanted to make that point. Yeah.
The point is that people keep asking, when will this thing be ready? In my view, T plus 13 years, as I've said elsewhere also. And that's a very aggressive timeline because these things typically take 15 to 21 years. But here, two countries are coming together, right? And you have much better computing resources today, especially AI based computing resources. What One thing we must understand, why this country has to run much faster, is because today you have to be a hardware company before you become a software company. Okay, if you have generated a lot of your own data over the years on working on things, then you are definitely at an advantage today, because you can feed that into your own sort of NLP based model, right? You can feed it into your own AI model, train your AI model using all the data you've generated over the years, and that AI model will do many things for you that would have taken years for you to do using the old methods, the
Life
semi manual
modeling,
method.
for instance. Yeah.
Yeah,
Yeah.
you
So stuff
style
like life
old style
modeling, right?
CFD.
Even before you build your first technology demonstrator, you can build a digital model and run it and see
Yeah, and
what the model throws up.
if you've trained your AI model well enough, it'll fix many problems for you with your first cut design. It
Hmm.
might even offer you a new design on its own, the way things are going. So
Yeah,
So,
it's
so
not
those
far fetched. There is a
not far
company
fetched at all, not
in
far fetched.
UAE who have an AI model which created a brand new ramjet engine design. So it's not out
Exactly,
of
and it is
uh,
working on the bench also, by the way.
yeah.
Yeah. No,
So
and
it's not
rocket
science
engines as
fiction.
well. They've come up with, and those are very strange kind of rocket engines in the, as far as the throat and nozzle design is concerned.
Yeah,
They're very unique, but they work. We'll have to see how well they work. We don't have data on exactly how well they work,
but
but that
that's
is
where
the
things
point.
are.
That we are in a different kind of a world now. But so all the stuff, so if you can get what is the real thing that the French will bring to the table, it is basically years of data. That is what they're really bringing to the table over here. Years of data, which is far in excess of what we have, right? But to leverage all that is being done, first of all, our IIP, our Indian industrial partner, has to be on board from the very beginning, not later. Even as you progress towards TRL 6, Indian industrial partner should be on board. The second thing that needs to be done is that we should also have other programs running in India. We should have a KDE follow on running, for instance. Why have a stealth? See, this is whatever it is supposed to power, which is now just being called an RPSA, is also going to be our first sort of major iteration or major iterative effort. In the future, you're going to have RPSA Mark 2, RPSA Mark 3. You will need stealthy engines for those, right?
Yeah.
Engines which have much better signature management. So you must keep improving the KDE as well, the KDE baseline, which works. You should work on that, and you should generate a wealth of data using it, using the RPSA, and you should work on faster iteratively work on new variants of that. And one of
And
those variants could easily be used in a cluster format to power Shriram's wet dream of a four-engine flying wing bomber. Okay, so
oh,
the
that is
Indian
definitely
Ocean region
happening.
and other places.
Yeah,
So
when I become the dictator, that's the first program I'm sanctioning. Just to add, right, about technology development. So the picture you're seeing is of brush seal. It looks like a ruler or a small paintbrush or something, but it's actually a brush seal. So these are seals that go against rotating components to create seals, right? So that air doesn't escape and sticks to the channel where air should actually flow. There are lots of rotating components and static components, right? So you have the engine's casing, and then you have a shaft running. There are blades and everything, so, right? So there are seals that are used to prevent air from leaking out. Air leakage is a major cause for reduced efficiency in any engine for that matter, but especially in military engines where the limits are pushed. So even stuff like this is difficult to make, difficult to design, and let's say get near to perfection, right? So these are small components that we need help with to get to cutting edge and to make sure that we're not doing any mistakes, right? So it might seem like a very small component when you talk about a big turbofan engine with big blades and a combustor and exotic alloys and everything. But even for stuff like this, we need help. So doing a joint venture like this makes a really big difference. I mean, we let's stop aggrandizing ourselves. We definitely do need the help. We don't have a working engine. So the whole point of spending so much money is perfectly justified. And we're looking at tens of thousands of crores, and the test facilities that Saurabh was talking about, assume each of them costs 2,000 crores. And if we need 4 such things, right, high altitude test bed, open air test bed might not cost so much except for land. High altitude test bed, component level, module level test facilities, a flying test bed, all of these, assume give 2,000 crores per head, and it's still less than 10,000 crores. Right, with change left over for power consumption.
Yeah,
Let's assume.
and a bunch of, and the leftover will also have components of specific manufacturing capabilities, right? Those
Correct.
will
So,
also be
so,
put in place.
so all that money is required. So we need to put in the effort. We need to get in people, recruit new people, set up a new, organization structure where it's not just the GTRE engineers who are doing this work, right? You need to pull in people from the private sector industry. If you've read our interviews with or watched our interviews with folks at ADA, you would notice that it's not just the people at ADA or any of the DPSUs who's doing work on all of these aircraft programs, right? We're taking in a lot of people on contract basis. You can argue the point of how efficient it is or not, but we're still pulling in a lot of people from outside. The same thing will happen with the engine business. And remember, a lot of our industries are very, very keen on this, right? Because aerospace is a lot of money. So they will want to participate right from the design phase itself.
Ballpark, I would say this engine will cost nothing less than $22 to $25 million a piece. The kind of engine that is being envisaged, right? So even if you get to build 200 engines, that's a lot of money. That's a lot of money. and,
Yeah,
and you're going to have a
and the
decent sort
same
of.
companies will be in the forefront of building civilian engines, and civilian
Yeah.
engines is a big volume market, unlike the military.
So,
So
bottom line is the Indian industrial partners have to be onboarded from the very beginning, not after you reach TRL 6 or something. And I'm not saying this on the basis of what is actually being negotiated or anything. I'm not saying it on the basis of that. I'm saying it on the basis of what I have seen over the years. Okay. So it should be very clear that Indian industrial partners have to be on board from the onset. They need to be part of the big discussions from the onset. It should not happen later. It should not be a discussion only between GTRE and Safran. Okay, it has to be the IIP, whoever is selected or whatever, it has to be on board from the very beginning in the discussions and in what is basically called the initial development phase. So we have a situation where a lot of people think, will this work? Will that work? I have a feeling this will work. It's really a question of how much more can we get out of it. We will have a working engine and a producible engine by the end of this effort. The question is whether we will gain everything that we want or not, like the way the Chinese have gained through via Rolls Royce and Safran over the years. Even without, a lot of people say the Chinese put so much money. The Chinese, where do you think all that money went? That is the question that you need to ask yourself. Where did all that money go that they put in? Did it go only to Chinese institutes and Chinese industry? That money, you see, I'll say something else now as an aside. In the years after the global financial crisis, and especially after the sovereign debt crisis in the eurozone, okay, a lot of things were up for grabs, and that is when China swooped in. You can see where China was in the aerospace sector in 2011 and where it is now. There's a world of difference. And that has everything to do with both push and pull factors. The push factor was the fact that, Europe was hard put budget wise. They were all looking for partners, blah, 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 and all that. And the pull factor was the sheer amount of money the Chinese were willing to throw at them. That was the pull factor. So a
true.
lot of all this has already been done. Okay. Yeah, you're going to say something. Go ahead.
Yeah, just a small anecdote, right? If the Chinese are willing to put in enormous amounts of money to get Western carrier fighter pilots to come and train and give knowledge to their own carrier aviation pilots, you can imagine the kind of money that they would have put in for getting any sort of information about engines or aircraft or electronics for that matter from the West.
Sriram, what is called Chinese espionage is nothing but Chinese buyout. Okay.
Buyouts.
All this APT2, APT3, and APT-XYZ, advanced persistent threat cyber espionage, all this is a cute way for Western manufacturers to basically leak data to the Chinese, and which has already been pre-arranged. Somehow they are never able to plug the gaps. Okay, the Chinese are so good at cyber. The Chinese are being made out to be 9 feet, 10 feet, 12 feet tall all the time. Whereas the reality is that their pockets are 9 feet, 10 feet, 12 feet deep
Deep.
for such activities, and the West is always up for sale. There is a very eminent retired scientist had one told me many years ago, many years ago. He said, you can ultimately buy anything you want. It's a question of how much money you're willing to give for it. Okay,
Correct.
in these arenas. So that is you see, because the cost benefit analysis is like this. If you are willing to give XYZ billion dollars for something I have already worked on and developed, then it makes it so much easier for me to work on the other thing. That is the Western outlook on such matters. You see, except America to a degree, because America has other. America might be arm twisting you on some other deal worth, a gazillion billion dollars somewhere else. So that may be its real outlook. That is why it might be calibrating you. But that is not the case with the rest of the West, especially the Europeans, the
Yeah.
Western Europeans. They are
So
much more commercial in their outlook,
yeah,
more than the Americans are.
yeah. Coming back to the previous point, right, about private sector involvement, especially in India, uh, we have a big materials problem, right? So that has been a bane for decades for us because we do not have an industrial society. We don't manufacture a lot of things. Our, focus or let's say strength, lack of strength in the materials field is well known. So when you talk about manufacturing, especially making sure that the whole engine can be manufactured in India, there are very few companies. So there are very few companies in India, in the private sector, who can help in manufacturing or even making the raw materials needed for your industry to manufacture with. So we're talking about companies like Investment and Precision Casting, PTC, Midhani. Midhani is a DPSU, but I hope the point is put across, right? So where there are these sort of companies who form the bedrock for your entire aerospace industry as a whole. And once we have these programs, we will always have the need for developing that better material, that better design. So it will continue to pull students into these fields because the demand for such professionals will remain or maybe even increase, right? So the reason an IIT Kharagpur material science guy who goes on to become Google CEO is because there was never any scope for the material science guy to do much within India. So if you look at countries or industries who've around the world who've developed their own alloys, right? Especially with respect to aerospace, you can count the number of countries on a single hand. We across the space and defense industry, we aim to indigenize alloys that somebody else has already made, right? Be it rockets, be it engines, be it airframes, space structures, rocket engines, whatever it might be. Somebody else has put in decades of hard work and created new alloys based on their own experience, expertise, and hard work and money. So that kind of capability has to be developed here, right? So that will only happen if you have an industry that is thriving and pulling people in and putting these demands on the academics and R&D groups, saying, this is my requirement and this is beyond what anything today can do. Can you build something for me? Right. So
Yeah,
these are
the funny
the
part.
stuff that your next generation products are built on.
The funny part. A certain alloy was developed by DMRL for the GTX 37, program. The GTX 3714U program. A certain alloy was actually developed by DMRL. Alloys can be developed, and the cost of developing new alloys is also going down with the advent of AI.
Mm.
Right. So new things can always be done. The question is, where do you want to head as an aerospace power? Do you want to be in the front ranks of the world or not? And that cannot be done on the cheap anymore, or ever, really. And this is the last window really to move forward, and I am, in a sense, I am happy that it has happened. Upili Sridharan is making a point about us subsidizing the French for a sixth generation engine, while we they give us a watered down fifth generation engine. We will have to give them something, and what we can give them is money and our own human resources. but there are many ways in which we can get much more value out of this than otherwise. Suppose we had just dropped all of this money onto our own programs, it may not have yielded exactly what we want in the kind of timelines that we want.
Yeah,
We are
that's the issue.
de-risking the program over here. Actually, we need to spend even more money if we are really serious about
Yeah,
jet
I mean
engine
that'll probably
development.
happen later.
But this is, in my view, the right step. There are a number of nuanced things that have to be done as part of this step, which we will not elaborate upon, which I'm sure the government is also thinking about. But they have to be done to make sure that we get value for money. The Chinese know how to get value for money, by the way, in many ways. And see, if we can jump all the way to a fifth generation plus engine via this effort, I think this effort would have been really well worth it. And see, the French are in no position to come up with a variable cycle engine either in a 10-year time span. They will
Yeah,
also take maybe 15 years to do that. So a lot more can happen once this gets off the ground. A lot more can happen. That initial development phase and the negotiations that will have to happen under that are going to be key. And like I said, the private sector has to be involved from the very beginning, the Indian private sector. Because see, I'm sure Hal Koraput and Midhani and all will definitely be involved. DRDO will be the one leading it anyway, and GTRE and DMRL will be involved. But the private player that we are going to choose for this also has to be in the mix. Now, again and again, assuming that a private player will be chosen for this. We don't know. They may decide to go with Hal Koraput itself. But I think there should be some sort of a competition then to choose who's going to be the main private player. But I have a feeling it's going to be a major private player, and all the MSMEs are also going to be there in the mix. It's not just going to be the established public entities. So, and
yeah.
that would be the right
I
way to
don't
go about
think
it.
we would have Hal Koraput doing it. I do not see that happening.
No,
Um,
no, but Hal Koraput has to be in the mix also. See,
hmm,
when you do have a Hal Koraput, there's no question of not using it either because of all
yeah.
the years of investment that has gone into Hal Koraput.
Hmm.
But we have private players in India who are addressing a large part of state-of-the-art engines, especially high bypass turbofans and commercial airliner
Yeah.
engines. So we need to be able to we need to leverage them properly as well. So
Right.
the consortium that we sort of build from the on the industrial side has to be a proper consortium. There should be no typical politics over there. Oh, these guys are going to gain.
Somebody
We are
going
not
to
going to
court
gain this,
because
that.
somebody else became L1.
And this is where the government will have to just use its authority to make sure that everybody behaves as it were. In my view, we cannot have
Yeah.
the usual kind of push and pull that goes on in India.
Mm-mm.
Hmm.
So we're taking a
Anyway,
few
let's go to
questions
our
now.
final
Yeah.
question and then we'll sort
Yeah.
of wrap
So
up.
Dheeraj makes a point. M88 T-Rex for Tejas 1A, JV engine for Ramka and Mark 2, new engine upgrade with variable cycle. The T-Rex might not happen because the French, right? They're like the shrew in old tales. They'll want millions for every single thing that you want. Like the TEDBF PD said long back, right? So if we do develop this engine, the new engine, it'll go across the Tejas fleet. The 404 replacement may or may not happen. We might end up with a Tejas Mark 1A fleet with just the 404 engines, but everything else will transition to the new engine. Because dimension wise, we're looking at one generation or maybe even 1.5 generations jump from the 414, right? So invariably, if you see over the past many decades, if you see thrust jumps, the dimensions go down. So and we're looking at an engine which is very similar to the 414 in terms of size and weight and all. So replacing all of those engines with the new engine is the plan, right? So we might not have the T-Rex sort of an engine on the Mark 1A fleet. It might happen, I don't know, but I don't see it happening anytime
The
soon.
T-Rex would only be a like a T-Rex would only be a, what should I say, only be a contingency at best. But I
Yeah.
don't think so. I think with this engine effort getting off the ground, the Americans are now going to make sure that F404 IN-20s come on time and the
Yeah.
F414 deal goes through, okay? Because
Yeah.
they will not want to miss out on that opportunity anymore. This is
Mm.
another reason why this was so important to go forward with this. And
Yeah.
we must also, like I said, the amount that has to be apportioned for engine development is going to be substantial. It is going to be in excess of the 61,000 crores at the end of the day. We'll
Yeah.
have to run multiple programs. Anyway, with that, I think we'll have to bring this episode to a close. I hope all of you stay well. We are also going to keep sort of bringing to you our views about the evolving picture, if you like. And with that, as always, Jai Hind. Good night.
Yeah. Thank you and bye bye.